So we'll be continuing our work with solving quadratic equations with these notes. And if you've been watching from the beginning, we started with graphing parabolas. And if you remember from the graphing parabolas notes, the solutions to the quadratic equations were the x-intercepts. And they were also called zeros. And so that's going to be really important for solving these algebraically, is having that concept solidified, because when you solve, today we're solving by factoring, and there's other methods as well, you're going to be setting the equation equal to 0. So you're trying to find all the values of x which make the equation equal to 0, and that is why they're called zeros. So the steps to do this are: 1, set the equation equal to 0. So everything goes to one side of the equation and 0 goes on the other side. So if you have to rearrange the equation to get that to look that way, then that's what you have to do. Step 2 is to factor the polynomial completely using all the methods that we know. And so the factoring methods that we have learned are GCF, grouping, and the AC method, which you may know as big X. So we'll use one of those methods. Oh, also the difference of squares pattern, which is really just a different way to do the AC method for a very specific situation. But those are the ways to factor a polynomial. And so we set the equation equal to 0, factor completely, so we get our factors of the polynomial, and then we set each factor equal to 0 and solve. Because if the equation equals 0, and so you can look at this first one as an example, we have these two things multiplied together and they equal 0. So that means at least one of them needs to be equal to 0. And so we find the numbers that make either one of those factors equal to 0 and solve. And then we can just list out the solutions. So these first three are already factored for us. So everything is set to 0. We got 0 on one side. This polynomial has been factored, so we don't have to do that part. So we just set each factor equal to 0 and solve. And you can typically do this mentally once you get to this point. It's pretty straightforward to just think about what number it would need to be. But we can also set them equal to 0. So we have x plus 4 equals 0 and x minus 5 equals 0. Because they're being multiplied together, the product is 0. So we need to see what values of x give us 0 for one of these, which would make the entire thing equal to 0. So we just solve each one. Here we subtract 4, so x equals negative 4. And here we add 5, and so x equals 5. And you can just look at that original factored form and know that, okay, if I have negative 4 plus 4, that's going to be 0. Or if I have 5 minus 5, that's also going to be 0. So you can kind of do that mentally as well. Either way, the solutions are negative 4 and 5 for this problem. So it's kind of just, especially when there's no leading coefficient, when it's just a 1x, it's just whatever the opposite of that number is. So for number 2, we can look at these factors and we know that we have y plus 1, so it's going to be negative 1. And y minus 3, it's going to be 3. Because you want the numbers that make them 0. But you can always just set them equal to 0 and solve them if you're not sure, if you want to make sure. So we subtract 1 and y equals negative 1. Or we add 3 and y equals 3. So again, these are already factored for us, so we don't have to do that part yet. We're just kind of seeing at this point how the factors give us our solutions. And for these notes, the factors will all be relatively simple like this with a leading coefficient of 1. But further on, we will look at other situations. And for number 3, again, we can just go ahead and know 5 minus 5, that's going to be 0. Negative 3 plus 3. So we know that x is equal to -3, or actually, sorry, r is equal to -3 and 5. But again, you could always just write that out and solve by setting those factors equal to 0 and solving. So add 5, you get r equals 5, and subtract 3, you get r equals -3. Okay, so that's how you do it once you have it in factored form. And we have one more of these. So this is a little slightly different. We have the factored form here doesn't have two binomials. It has one binomial and one monomial. So this must have been a GCF, factored by GCF type of situation. So we still set each factor equal to 0. So this 3D is one factor. And then we have 5D minus 5. And again, or not again, but you can see that we don't have a leading coefficient of 1 for this one, so we do have to do a little solving. Okay, so 3D equals 0. We want to solve for D. Divide by 3. D equals 0. Okay, so typically when you have a GCF that has a variable in it like this, you'll get 0 as one of your solutions. For 5D minus 5, we have to add 5 to both sides. So 5D equals 5. And then divide by 5. And so D equals 1. So our solutions for this one are 0 and 1. Okay, so just take each factor, and sometimes it'll look slightly different. Set them equal to 0 and solve. Now, for the rest of these, I think we'll need to do some factoring ourselves. So on number 5, we have f squared minus 7f equals 0. We have to factor this polynomial. First, our first step is to set the equation equal to 0. And so we want to make sure that that is accomplished. And so, just make sure. And I think it is here on number 5. We have it. This is jumping everywhere. We have it set equal to 0 already. So now all we need to do is factor the polynomial. So the f squared minus 7f. And I think in this case, we're just going to take a GCF out. So we can take out an f. We're left with f minus 7. And I would be really careful as you work through these to make sure that you write everything down completely each time. Like, make sure you put the equal 0. Just kind of keeps it in your brain that that's what you're trying to accomplish. Is what does f equal here to make the equation equal to 0? So now we factored it, and we can set each factor equal to 0 and solve. So we have f. Well, if f equals 0, then that's it. And then we have f minus 7. So we just add 7. And 0 plus 7 is 7. All right, so those are our two solutions for this one. F equals 0 and 7. So again, we're factoring the polynomial portion, setting each factor, each thing that's being multiplied together, equal to 0, and solving each of them. All right, finally we have a trinomial to factor. So x squared minus 18x minus 40. And this is the AC method. We have a trinomial. And so you want two numbers that multiply to negative 40 and add to negative 18, right? Multiply to AC and add to B. And in this case, I think that would be negative 20 and positive 2. So we need to split that middle term, x squared minus 20x plus 2x minus 40. Factor by grouping now. So x times x minus 20 and 2 times x minus 20. And so we get x plus 2 and x minus 20 equals 0. Now, if you can factor a little faster than that, if you don't need to write down all these different steps, that is completely fine. Just really elaborating here for the notes. So once you get that factored, again, set each factor here equal to 0 and solve them. And just like we saw at the top, we can kind of just look at this and know we're going to get -2, because -2 plus 2 is 0. And we're going to get 20, because 20 minus 20 is also 0. So set them equal to 0 and solve. X plus 2 equals 0. X minus 20 equals 0. So again, it's really just the opposite of what's in the factor, in the binomial. For number 7, this thing is really jumping around. For number 10, rather, I think we skipped a row right to number 10. It says x squared minus 25 equals 0, and there's a hint, DOS. So this is referring to the difference of squares. So we have a difference of squares pattern here when we factor it. Now, for this particular problem, it might be easier to solve this one using square roots, just like we saw in the previous notes. You could add 25 to both sides and then take the square root. But since we're factoring for these notes, we'll go ahead and do that, even though we might choose to use a different method if we were just presented with this problem. But for these notes, we'll focus on factoring. So difference of squares, remember, is when you have a squared minus b squared, you can make that into a plus b and a minus b. So take the square root of each term here and then split that up into your two factors. So I know that this is going to be x plus 5 and x minus 5 because the square root of 25 is 5, which means my solutions will be negative and positive 5, positive and negative 5, because this one gives you negative 5 and this one gives you positive 5. So not too bad, but again, you could solve that with square roots and you would get the same answer. And if you would prefer to write your numbers in a list like this, that's okay too. All right, number 11, this equation is not set to 0. So remember, we have to do that. We have to get 0 on one side. So we need to bring this 18 over here. So we get x squared plus 11x plus 18 equals 0. Remember to do the opposite whenever you are eliminating something from one side of the equation. But now we can factor. So we need two numbers here that multiply to 18 and add to 11, which it looks like that's going to be 9 and 2. 9 times 2 is 18. 9 plus 2 is 11. So we'll split this middle term into those two numbers. Don't forget to keep that in mind that we're still equal to 0. Factor by grouping, so that's x times x plus 9 and 2 times x plus 9. So our factored form here is x plus 9 and x plus 2, which, remember, when you have a leading coefficient of 1, which we do, these two numbers that you find will be the two numbers that show up in your factors. So we could skip a lot of this work and go straight to the factored form, but for the notes, I'm going to write down the whole process here just so that everyone's clear with what's happening. But if you are comfortable enough to skip that part, that's okay. However, you've learned how to factor these, works just as well as long as you get the right answer. So our solutions here would be -9 and -2. Because those are the numbers that will make each of these things 0. Okay, last one here. Again, this equation is not set to 0, so we'll need to subtract 15x from both sides. And I kind of like to just line up where it's going to end up when I do this so that I kind of keep track mentally of where it's going to go. So x squared minus 15x plus 44 equals 0. Okay, so we need two numbers that multiply to 44 and add to negative 15. So they multiply to positive 44 but add to a negative. So because they add to a negative but multiply to a positive, we know they both have to be negative. And I think the numbers we want are negative 4 and negative 11. So let's split that negative 15 into those numbers. And factor by grouping. So get x minus 4 over here, take out an x, and we can take out a negative 11 and get x minus 4 as well. So our factored form, we've got x minus 4 and x minus 11. And so we can set those equal to 0, solve, and we get the two numbers 4 and 11. So 4 minus 4 is 0, and 11 minus 4 is 0. Okay, so that is the process for solving by factoring. Get your equation set to 0, factor the polynomial that's on the other side from 0, set each factor equal to 0 to figure out which values of x give you those solutions, those x-intercepts for the equation.